Okay. So here we have the types of matrices. Row matrix, a matrix which has one row, and a column matrix is a matrix. This is one row matrix. A column matrix is a matrix which has only one column. It can have any rows. Zero matrix is a matrix which is having all the elements as zero. And a square matrix, the number of rows should be equal to the number of columns. Then we have diagonal matrix. Diagonal matrix, a matrix in which diagonal elements except diagonal elements. If all the elements lying outside the diagonals are zero, all elements except diagonal elements except diagonal elements are zero. Means it should be a square matrix. Diagonal matrix is always a square matrix or a square matrix with all elements except diagonal elements are zero. So we can say suppose A is a matrix of 3 by 3. So A 0 0 0 B 0 0 0 C. This is a diagonal, as I told you. This is a diagonal. These are three diagonal elements. Huh? So all other elements are zero except diagonal elements. Okay. Then we have scalar matrix. Next is scalar matrix. Scalar matrix is a special type of, you can say, special type of diagonal matrix. In diagonal matrix, we have seen all the diagonal elements are non-zero. Other are zero. That means A, I, J. We are denoting a matrix by A, I, J, M into N, M rows, and M columns. So M into M, yeah, N, we can say N only. We can write N only. So that means N by N. So it has all elements 0, A, I, J is equal to 0 when I is not equal to J. This is for diagonal matrix. Because if we write diagonal elements are A11, A22, A33. So for all diagonal elements, I is equal to J. And for all other elements, I is not equal to J. For these elements, I is not equal to J. So in scalar matrix, if a scalar matrix is a diagonal matrix in which diagonal matrix with all diagonal elements are equal, with equal all diagonal elements are equal. For example, if different elements are different, then it is a diagonal matrix. If all elements are equal, for example, 2, 0, 0, 0, 2, 0, 0, 0. So all elements are equal, then it is a scalar matrix. Okay. You can write Aij condition will be equal to Aij will be equal to 0 for I is not equal to J. I is not equal to J, all 0, and it is equal to constant K, any constant when I is equal to J. This is the general definition. You can write this also. Then very important matrix, that is a unit matrix or identity matrix. It will play a very important role later on. Unit or identity matrix. Unit matrix is a square matrix. It is a square matrix. First of all, it is a square matrix. All are square matrix. Scalar matrix is also a square matrix. Square matrix, a square matrix with all elements are 1. A square matrix is a square diagonal matrix. A square diagonal matrix with diagonal elements are 1. With diagonal elements are 1 only. For example, 2 by 2, if we will write 2 by 2, we used to write I or I2. I2 means 1, 0, 0, 1. Identity matrix. I3, we used to write I or I3. Yeah? Sometimes I2, I3, but generally we are using I. So 1, 0, 0, 0, 1, 0, 0, 0, 1. It is an identity matrix. Okay. And this will multiply with any matrix. It will not effect on any matrix. That is why it is called identity matrix. So these are the types of matrices. There are many other types also, but we are going according to CBSE as of now. Later on, we will discuss more types. So now equality of matrices, then we will complete our exercise. Equality of matrices, two matrices are said to be equal if equality of if they have same order. Okay, the two matrices are said to be equal if they have same order. Then their corresponding elements are also equal. So they have same order. If two matrices are same order, then they are said to be equal and their corresponding elements are equal. Means we can equate their corresponding elements are equal. Corresponding elements are equal. For example, suppose A, B, C, D. This is a matrix of order 2 by 2, and if it is equal to the matrix 1, 2, 3, 4, then we can say that their corresponding elements are equal. We can equate A is equal to 1, B will be equal to 2, and C will be equal to 3, and D will be equal to 4. Okay, so like this we can have equality of matrices, and by this equality we will do many questions. Doubt in question number 5 you can ask now, otherwise we can go ahead. Okay.
Yes, sir.
Okay, so in these types of questions we have to just equate the elements and find the value of x, y, and z. Here, this is very easy. Y is equal to 3, z is equal to 4, x is equal to 1. Question number 1. You can directly equate x is equal to 1, y is equal to 4, and z is equal to 3. Here you will get two equations. X, three equations. X plus y is equal to 6. Then 5 plus z is equal to 5, and xy, the third one is xy is equal to 8 on equating the corresponding element. What will you write on equating corresponding element? So from this, z will be equal to 5 minus 5, 0. Okay. And solve these two equations, x plus y. So y is equal to 6 minus x. So x into 6 minus x is equal to 8. Multiply. So 6x minus x square is equal to 8. So x square minus 6x plus 8 is equal to 0, and solve to get the value of x.
Sir, x will either be
So
2
x
or
will
4.
be equal to 2 and 4. So x is equal to x is equal to x is equal to 2 and x is equal to 4, correct? And we can find the value of z, y, sorry. So y will be equal to 6 minus 2, 4, and 6 minus 4, 2. Okay, so similarly, you have this equation also, so you can do it, I think. Next question is also same. We have to equate values and solve it. Then question number 8. A square matrix. Yeah, a matrix is a square matrix when m is equal to n. Number of rows is equal to the number of columns. Which of the following values will make the pair of matrices equal? Equal means x is equal to, you have to find the value of x will be minus, like this, minus 7 by, when you equate it. So this question number 9, answer will be B, or option will be B, because when you find the value of x, 3x plus 7 is equal to 0, and x will be equal to, and y plus 1 is equal to 8, so y is equal to 7. So we are not having that value here. So by equating, we can find the value of x and y that we did in the previous question. This question you were asking, actually this, if you know the permutation, n raised to power n and npr. So here it is the repeated one. So we have the two entries. We can enter 0 or 1. We have two entries. What? 0 and 2. And how many places we have? 9 places. 3 3 is 9. 3 by 3. How many 3 by 3 possible matrices can be made by using 0 and 1 only? Means we are putting 0 here, then 1 here, somewhere other 0, anywhere we can put 0 and 1 to make the matrices. So how many possible entries? So there are 9 places, and we have to put the two numbers at 9 places. So answer will be 2 raised to power 9. 2 raised to power 9. The number of possible matrices of 3 by 3 order with entry 0 to 1 is equal to 2 raised to power 9. That is 512. Yes, so 512 ways. There are 512 ways of making the number of matrices with order 3 by 3, and each entry is 0 or 1. Got it now? Hello?
Yes, sir, I got it.
Okay, got it? Okay.
Yes,
So addition of matrices. First, we will see how to add the two matrices. What are the conditions in which we can add the two matrices? So two matrices are given. Then first of all, we have to see what is the condition to add them. Okay. So they must have, there are two conditions. Number one, they must have same order, means same order matrices can be added. Means if a matrix is 2 by 3 order, we can add with 2 by 3. We cannot add 2 by 3 matrix with 3 by 2. Okay. And for adding, what is the procedure of adding? The procedure of adding is add their corresponding elements. Add their corresponding elements and same order element, same order matrix you will get. For example, A plus B, we have to add A and B. So A has elements A11, A12, A13, A21, A22, A23, A31, A32, A33. This is suppose matrix A of order 3 by 3 and matrix B is also having same order 3 by 3. Its elements are denoted by suppose B11, B12, B13, B21, B22, B23, B31, B32, B33. When you will add, you have to add the corresponding element. Means A11 is added with B11 only. You will have the first element of the sum is B11, A11 plus B11. Second element will be equal to A12 plus B12. And third element will be A13 plus B13. Okay, like this A21 plus B21 and so on. Similarly, A31 plus B31, A32 plus B32, like this you will add. Say for example, suppose 2 by 2 matrix 1, 2, 3, 4 is added with plus 5, 6, 7, 8. So the answer will be 1 is added with 5, 5 plus 1, 6, 6 plus 2, 8, 7 plus 3, 10, 4 plus 8, 12. Like this, we can add any two matrices. Then multiplication of a matrix by scalar. If any number we have to multiply with the matrix, so it will multiply with all the elements. For example, the multiplication of matrix by a scalar, means by any number, then it will multiply. You can see that if k is multiplied with this matrix 1, 2, 3, 4, it will multiply with all the elements. In matrix, it will multiply with all the elements. K into 1, k, this will become 2k, 3k, and 4. So you can write in general, if K is multiplied with matrix A. So K is multiplying with matrix Aij of order m into n. So it will multiply with all the elements K into A I J m rows n column. Okay. So this is the first operation, addition. Then properties of addition is, we should study the properties, because in multiplication some properties are not followed by multiplication. Similarly, difference is also the same. Difference is also same. We can find the difference is the sum actually. So if we are finding A minus B, this will be equal to A plus minus 1 into B. That means this minus B scalar will multiply inside B. So it shows that we have to subtract the corresponding elements directly. We can subtract for difference of two matrices. Commutative property, negative of a matrix is denoted by minus A. Is noted by minus A. So we can write minus A or minus 1 into A. Is minus should be multiplied with all the elements, it will become negative matrix. And difference, we have seen that difference multiplication. Commutative property, we can add in any order. If A plus B, if we add B in A or A in B, it is same. So commutative associative property is also followed. A plus B plus C. You can add any two matrix first. That is associative property. Existence of identity. Identity is an element which, when added with any element, it will not affect on that element. That is called identity. So here identity matrix is a zero matrix. Zero matrix is an identity matrix for addition. Zero matrix is called identity, additive identity matrix. Additive identity, additive identity for matrix addition. For matrix addition. Operation, binary operation is matrix addition. So here the additive identity will be zero, and existence of additive identity means existence of additive inverse over here. This is additive inverse is a number which can be added to give the identity. So if in A we will add minus A, then we get the identity matrix. So negative of every matrix is called additive inverse of A. This is called the additive inverse of additive inverse of matrix A. Then we have scalar multiplication. These are the properties, as I told you about the properties. K can be multiplied inside, or directly we can add, or we can multiply first. So these are the simple properties which will be used in these types of matrices. Here you can see that we have to find this matrix 2A plus 3x is equal to 5. We find x. So we have to find x. So other will be transposed on right hand side first, and then substitute the values and just apply the given operations. So we will go to the exercise now. Multiplication also shown before the exercise, but first we will do the questions on addition. Then tomorrow you'll see the multiplication. It will take time. So in the starting, we have simple type of question that you can do easily, addition, subtraction. But now for the time being, you leave the multiplication part, this one and this one. So these all are addition. So we can add a plus b, 2 plus 1, 3, 4 plus 3, 7, like this. I think easy to do it. 3a minus c, first you have to multiply 3 inside a. So how will you do 3 and substitute the value of a? 2, 4, 3, 2, minus 2, 5, 3, 4. Now multiply 3 inside, 3 2s are 6, 3 4s are 12, 3 3s are 9, 3 2s are 6. First multiply and then subtract minus, and minus 2, 5, 3, 4. Now you can subtract 6 minus minus plus 2, 6 plus 2, 8, 12 minus 5, 7, 9 minus 3, 6, 6 minus 4, 2. So this is the result. So similarly here you can add directly. Here it is addition. So you can add them. First you will get a square plus b square plus 2ab plus 2ab, because I'm just writing the result of the addition of these. So this will become a plus b whole square. Similarly, b square plus c square, second element of the first row, b square c square plus 2bc. Is it visible? A square plus c square, a square plus c square minus 2ac, and a square plus b square minus 2ab. Okay, so this will become a plus b whole square, and this will become b plus c whole square, and a minus b whole square, a minus b whole square. That's all. So here this is multiplication, this is all products, so don't do it. I will tell you multiplication tomorrow. This one you can do it. Question number 4. Just note down, you can do the question number 4. This. So wherever you will find addition, subtraction, you can do that questions. Okay. And sometimes we have the question where we have to solve the equations, like question number 7, first part. Here you have 2 equations you have to solve, but in matrices. So we don't have now time. So we will do tomorrow these types of questions. Okay.